Welcome to the Real Python Podcast. This is episode 40. Have you wondered how Python manages memory? How are your variables stored in memory, and when do they get deleted? This week on the show, David Amos is here, and he's brought another batch of PyCoders Weekly articles and projects. Along with the Real Python article on Python memory management, we cover another article about creating even and non-even spaced arrays in Python with np.linspace. We share an article titled The Unholy Way of Using Virtual Environments. This leads to a discussion on how to structure the directories around a virtual environment. We also cover several other articles and projects from the Python community, including storing a list in an int, why you should use an ORM, unraveling not in Python, an open source Python Fuzzer, and Python static website generators. Okay, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, David, welcome back to the show.
Hey, Chris. Thanks for having me back.
Do you want to start off this week talking about your first article?
Sure, yeah. So the first one I've got on my list is a Real Python article called np.linspace, create evenly or non-evenly spaced arrays. This one comes to us from Stephen Gruppetta, who is one of the newest authors on the Real Python team. It's about the np.linspace function, which is used to create, most people think of it as creating evenly spaced arrays of numbers. If you want to create something that has maybe like starts with 0 and goes up to 100 and is taking steps of like 10 between each consecutive number in the array, you do something like linspace, and it stands for like linear space, right? They're spaced linearly. It doesn't have to be evenly spaced. So you can use linspace to create something that's not exactly an evenly spaced array of numbers. So this article is very comprehensive. It goes through all of the parameters for the linspace function, how to control things, have finer control over the types of the values, setting your endpoints, things like that. It gets into some interesting examples of it. So he has an example where you kind of go through and model like a food production conveyor belt.
Okay.
And you use these arrays to help you model that kind of a situation. He also talks about how you can use arrays like this to represent mathematical functions discretely. So if you have a continuous function like a polynomial, and I mean, you could say create a Python function that takes some number x and returns the value of that polynomial evaluated at x, and then you could use this to create like an array or something. But that function is just like, you get the input and the output, but what if you want to like graph that function, or you want to use the values of that function as sort of input into some other algorithm? Well, you need a way to represent not just the function, I guess, as like where you take an input and give an output, but you need a way to represent the function as like a collection of data. And you can use the linspace function and the arrays that it produces to do that. So he talks about that, which is helpful in a lot of situations, obviously in things like scientific computing and data science and things like that, but also getting into graphics and just modeling and stuff like that can crop up in a lot of different ways. So that's a kind of a cool application. But yeah, it's just a lot of good stuff in it. It's incredibly comprehensive, lots of great plots and things to look at. So fantastic job, Stephen, on the article.
To take a step back there, so the NP is standing for NumPy, right?
Oh, yeah. Good to point that out. Yes, it does. Stands for This comes from the NumPy package. So this is the linspace function in that, and it returns a NumPy array.
And those are advantageous for a lot of data situations because of the, it's more of a C implementation, and so they're a little bit smaller. And
right.
Yeah. Okay.
Yep, there's a lot of advantages of using NumPy arrays over something like just a Python list. Or Python even has an array data structure. There's an array module with an array class in it. And those are good if you want like a pure Python implementation, but they're still not quite as speedy and efficient and everything as the NumPy arrays. So
awesome. So my first one is, it's a really interesting one. When I saw the list of articles on PyCoders, I was like, okay, well, this looks kind of fascinating. And it's titled The Unholy Way of Using Virtual Environments. And it's by Bhupesh Varshney. Mm-hmm. It's on his development blog. And you've probably heard us talk about virtual environments before on the show. And we're definitely both proponents of using them. And I typically use the built-in tools that come with Python, the venv command, and use that for building my virtual environments. But there are different ways or schools of thoughts here, and this definitely has a very unique one. So He starts out with these three different ways, and the first one is he considers the moral way, or maybe would be considered like a very common way, and that you start a project folder, and as you're setting it up and you create a virtual environment inside of that directory, at that point, if you say start creating, a Git, you get a init inside there, you have to be aware of the idea that, okay, I need to make sure that I have like a git ignore file that is not going to include this virtual environment, and to make sure that I don't back up this entire coding environment and all of the stuff that goes with it there. And I'm guessing that's the struggle that this author's had with virtual environments, is that the idea of like accidentally putting them into there, and it might be just in, naming conventions or other kinds of things. Mm-hmm. Anyway, so the pros to this, he calls it the moral way, is that it's portable. It's easy to remove and create new environments. It's been a pretty common technique for me. Mm-hmm. Just create a directory, have the venv in there, and then, just making sure that if you're using Git and you're committing your stuff, that you just want to make sure it has an ignore file that ignores all that stuff inside there.
Right.
So, the cons that he mentions there is that accidentally committing your venv, and that could be because you're doing something interesting as far as naming and the constructions of your venv. So here's the second way, which he calls it the holy approach. Holy being like, HOLY. And in this one, it's creating a directory structure first, and then inside of that, having a project folder and a venv folder separate. And so in that case, the project folder is embedded separately, and that's where you're doing your git commit, and you're actually or you're initializing your git. And so it's not going to grab any of that stuff outside there. You don't need to add it to your git ignore. You can easily still swap environments like you can with the other one. And you can use custom names if you wanted to for things like that. The problem is it can be a little bit confusing in navigating. It's something that I've noticed often in something like a Django project, where you might have an outer folder like that, and then all of the applications that are inside of it, you end up with kind of this, duplicate naming, and you kind of just have to be aware of what you're doing inside of that. I don't typically do that one as much, but I can see the structure. And again, it might be, kind of just an organizational thing. So here's the one that's really weird. Is he calls it the unholy way. And this is to go ahead and create the virtual environment and then start building your project inside of the virtual environment folders and directory. And his reasoning is that you can't accidentally commit this venv. You don't need to bother with a git ignore, because it's already sort of embedded in this lower level directory that's inside the structure, sitting alongside the other areas of like the different things that are inside the virtual environment. The cons are huge on this one. Mm-hmm. It's really not portable. Yeah. And it can really cause some issues. He has a whole list of ways that he's created to implement this, shell scripts and things like that, to automate the process. And I don't see the need to do it, but I think there is a reply that's at the bottom of this article, this blog post, that really covers my opinion really well. The idea that the environment really should be this ephemeral thing that can be recreated on different people's platforms and so forth. Yeah. And then something that we've focused on a lot in other episodes where we've been talking about, the portability of code, and also the idea of there's different uses for the code. There's the environment that a developer is going to need. And even, somebody's like helping on an open source project, they would also maybe need certain libraries for including testing and things like that. So like this sort of shared development sort of thing where that environment may be slightly different, or it could be a thing where, again, you have like a testing and a production or what have you. And then, again, if it's an open source thing, there's this whole other type, which is like an end user is going to need a very different type of environment there. And so like it should, in my opinion, be an ephemeral thing,
Yeah.
with a different set of requirements. And I don't know, it's just an interesting idea. I think it's more of like just a structural thought. And I definitely approve of the first one, but again, that's something that I've been practicing. And I know there's even different schools of thought of like putting a dot in front of your VENV,
right?
Your environment that you're creating to keep it hidden on a lot of the operating systems. And so I can understand that too. But again, making sure that you're not you're not sharing all that code and putting that up in GitHub along with everything else. But anyway, it's an interesting article, interesting idea, and I think it, more than anything, it hopefully helps to illuminate different ways of thinking about this, but hopefully solidifying why one is advantageous to another.
Yeah. So I actually debated a little bit when I came across this article, like, should I include this in PyCoder? Should I not? Because there's not often a lot of context in PyCoders, like why certain articles get included. And it's like, are we endorsing something about this? Or do we just think it's interesting? Or like, you know what I mean? Like, first of all, when I read it, I was like, wow, okay. I don't think I've ever even really thought about putting my code inside of my virtual environment.
Yeah.
So it was something just sort of totally, he even says here when he talks about the unholy way, project is stored inside the virtual, and then parentheses, bet you didn't see that coming. And I was like, yeah, I totally didn't see that coming. That was not what right. what I thought was gonna be in here. But yeah, it's I think, the reason that I saw this and was like, I want to include this in PyCoders is because it sort of highlights something that I think is common among people, probably among absolute beginners, but I think even people who've been programming with Python for several months or a year and have some experience with that, virtual environments are not like this, they're not a super easy thing to like really wrap your head around and like really, like, and why would you do it one way versus the other? And what are they even used for? Like, what is this? So I think it really highlights like a need for better, I guess, education is the word around these virtual environments. And of course, Real Python, we have some really good resources on that.
Yeah, we'll link to that stuff, definitely.
But yeah, I think the comment at the bottom, which wasn't there when I originally read the article, sums it up pretty nicely, and also in a very critical but like not mean way. Like it's
not impolite or rude,
right? Yeah, it's just like, hey, here's kind of the reasoning for all this stuff, and it's the idea that like a lot of projects are going to have multiple environments. You're going to have an environment that's like what your project would be running in, like on a final, like in a production type environment. You're going to have a dev environment that's got like your testing stuff or like any like development tools. You might even have a separate test environment that you run your code in when you're running your tests. So, the dependencies might be different in each of those. And it really comes down to dependency management and some of the needs for that. And this issue of like ephemerality, is that a word? It is.
It's a good word.
Yeah.
I'll take it.
Ephemeralness. I don't know what the right word is, but yeah, I completely agree that these things should be ephemeral. Like you should not be afraid to just delete your entire virtual environment. Like,
right.
If you set things up logically, and I don't want to use the word correctly, but like just, yeah, you should be able to just delete it and then start over. You should have no issue with that. And obviously if your code is stored inside your virtual environment, like do not delete it. So one thing I wanted to mention, and we've talked about this on the show a while ago, there's a link in this comment on here to this tool called pip tools, which is used for managing dependencies. And you can create sort of like different files and stuff with it, like your requirements file for your production environment, your requirements file for your dev environment, your requirements file for your test environment. And you can manage all these and everything. I love that tool. I use it a lot. And then something else I just wanted to mention, because the author talks about like, yeah, if your virtual environment isn't stored in your project folder, then you have control over the name of it, and it doesn't have to be like VM for something. I just want to say that you do have, and it took me a long time to realize this, and I think it was an article by Brett Cannon, if I'm not mistaken, tipped me off to this. But there is, when you create a virtual environment with the venv module, so if you do like python -m venv, and then you type in the name you want, which I always use .venv, and it's specifically so that it's just automatically hidden by my operating system. And then after that, there's a prompt flag. You do --prompt, and then you can give it a quote unquote name, and it'll change what you see at the beginning of in the prompt in your shell. So like normally you just see like venv
right
there. Like when you activate your virtual environment, it says like venv, and then you have like your shell, whether it's the $ or, C:, or whatever. If you use the prompt flag, you can actually name it like your project name, or like project name -dev, or like whatever. So you have like more context there without having to like use a different necessarily name for the virtual environment. So I think, if you have multiple environments, you could have something like, .vm0, .vm1, .vm2, and then you could use the prompt to name that. And then it's easy to ignore, like in your git ignore file, it's just like VM star whatever, that ignores all VMs with a number after it or anything else. So anyways, yeah, just it was kind of a thought provoking, or like wow, like I wonder, like why would you want to do this? And I guess they laid out their case, and it's like, well, there's actually other ways to handle this that might be better. So anyways, it was just a really interesting article.
Yeah no, that's why I liked picking it. And then along with mentioning the pip tools like that you mentioned, the commenter add, he also added which Python, typing that out,
right,
to be able to know what Python are you running right now if you've activated the virtual environment, and then also pip list to know what is currently listed as far as part of the current environment, and kind of understanding those tools and getting comfortable with them just in general. Like were tools that I've learned kind of late that have helped me understand what's happening. There's a really good pip course that we have that I'll put a link to also that kind of goes over some more of these things. A lot of people might just know pip install or pip uninstall, and there's a lot of other things that are in there that you can kind of see what's happening inside what is currently installed and what's going on with it. So
yeah.
What do you got next?
So the next one I've got is another really interesting and sort of off the wall kind of article.
All right.
It's called Storing a List in an Int. This immediately piqued my interest, and I was like, I've got to check this out. Like, this is totally up my alley. And the concept here is that Python's integer type, unlike C or Rust or Go or something, a lot of these other languages, the integers in Python have arbitrary precision, or arbitrary, unlimited precision, which means that like there's no like maximum integer. You can just keep going until your memory runs out. So like the largest integer that you can store in Python on your computer depends on your memory.
Okay.
And that's it. Whereas in a lot of other languages, and especially like in C, you have like different sizes and they have different ranges, and are they signed or unsigned? Like there's all this stuff about it, and there's like very hard limits to like that's the biggest integer that you can store in this kind of integer type. And you just don't have that in Python. It's all handled for you behind the scenes, so you have this unlimited precision. Unlimited here is kind of like in air quotes, right? Like it's sort of like, sure. I mean, in theory it's unlimited, but it's limited by your hardware and not by like the language or anything itself.
It kind of goes back to the idea that I've had a couple of people on talking about pandas and ways to, make, again, we talked about NumPy, but also by selecting specific types that are not just generic ints, that are not Python ints, where you're picking a signed integer that's only 8 bits is only going to provide, this value. But if that's the range that you're working in, then that's going to make this way more efficient and much smaller.
Right.
And, things like that. And then you could go to like up to, 32-bit and 64-bit and so forth, and the multiples you get from there. So that totally makes sense.
Yeah. So one of the things that you get with this unlimited precision, and this is where, this may not occur to people that maybe aren't like the computer scientists or like mathematicians or think in those terms. But theoretically, if I can store any integer on my computer with Python and work with it with Python, then I can just represent all of my data as integers. And at first point, like that might seem like, wait, what? Like that doesn't make any sense. Like, how on earth could you do something like that? And it's like, well, it's not that far fetched. I mean, computers are already representing all data as bits,
right?
As collections of bits. So, and a bit is just a small integer. Like there's really, it's not super far fetched. So one of the things that this author is planning on doing, the author is Ian Taylor, by the way, should have mentioned that earlier, but what he's going to do is talk about how to represent many different data and data structures using integers. So this is really kind of the first article in a series where he's focusing on lists. So how do you take a list and represent it as an integer? In particular, he focuses on lists of integers themselves, or I guess that could be floating point, but he's using all integer values. Although I think that the method could be generalized to other kinds of data. It's just, this is kind of the easiest way to kind of get, kind of dip your foot into it. But the basic premise is based on something called Gödel numbering, which is named after the logician Kurt Gödel, which mathematicians either love or hate, because he's responsible for sort of killing a lot of hopes and dreams of some mathematicians, telling us that there's no logical system that could ever be 100% like you'd be able to determine the truth of every statement that was possible to express within that system. So I know that's crazy, like think about, but anyways, this does not have anything to do with that. This is a different thing that Gödel worked on called Gödel numbering, but it's a way that you can take an integer and sort of encode it with like a one-to-one function into like a list of numbers. And if you have any list of numbers, then you can take that and convert it back into some integer. So you can already see we're like, okay, well, this sounds exactly like what we're trying to do. So he goes into a Python implementation of this. There is some math involved. There's, using prime numbers and prime factorization and things like that. But if you're into that, I mean, it is a little bit of a kind of a headier kind of article. But if you're into this, and it's also like, this is not, and there's kind of a disclaimer at the beginning of this where it's like, look, I'm not doing this because I think that like, well, look at this, like this is a smarter way to do it, or this is better or more efficient. It's like, there's like none of that. And I don't know if it's more efficient. I don't care. I'm not going to benchmark it. It's literally just because I think it's interesting and fun. And that's really just what it is. So yeah, it's really interesting. And it definitely kind of got my mind spinning on like, yeah, I mean, how can we take this? I mean, obviously something like a tuple is a logical next step from here.
Right.
But one of the cool things about it is you think, okay, well, I can represent a list as an integer, but then what? I mean, if I'm storing my list as an integer, I need to be able to do stuff with it. Like I want to be able to append new items to the list. I want to be able to access items by index, as like sort of like the basic operations. I'd also want it to probably be able to like replace items at a certain index. I'd want to be able to like remove and, delete and remove and pop and like all the kinds of things that we associate with like the, methods on lists in Python. So he puts together an append method and an access, not methods, they're actually functions because they're not on like a class or anything. But you're doing that where you're not like casting, so you're not like storing the list as an integer. And then when you want to like append something to it, you like convert it into a Python list, append it, and then convert it back to an integer. All the logic is happening at the level of like, it's still an integer. And there's like logic of like, okay, if I were to append this at the end, how would that affect? I'm going to get some new integer. Like my list is not going to be the same list anymore. So it's going to be some other number that represents it. And how do I calculate what that number is? And so the idea of appending doesn't become now it's like, oh, you're just tacking it onto the next index. It's actually calculating the number that you would get if you had done that operation on a Python list. So anyways, just really fascinating. It just was a really fun read. someone else out there might like it too. So
Yeah.
there you go.
Think about having fun with the levels of math you can kind of dig into. But I know that's everybody, I think a lot of people that are programmers are into puzzles in the same way.
Yeah.
So, well, my next one is going off a topic that we covered. We mentioned another Real Python article that Doug Farrell put out a few weeks ago that was about using SQLite and SQL Alchemy and the advantages of moving from flat files into using SQL. And this one kind of focuses more on the why of using what's called an object relational mapper, which is an ORM.
Mm-hmm.
And that's literally the title of the article is Why Should You Use an ORM? And it's by Karim Marzouk. His blog is the Monadical blog or Monadical, depending how you want to pronounce monad. Or it starts out talking about data inside of Python, and we've been focusing on that for a little while. Doug's article kind of focused on kind of bringing in flat files, and this is kind of saying, okay, well, what if you start out with just the raw data inside of a Python application, and then you start building pieces of data. In this case, the example he uses is kind of a common one, especially if you've ever messed with Django. You might have seen this creating a poll application where you create a question and then you're kind of creating votes or choices for a particular question or answers for them, and then being able to store that. So it starts out with using some data classes to create a few questions, and then where it would store choices for that. And at the beginning of that, okay, you have these pieces of data, but then what happens when you want to, say, stop that application? Well, normally in Python, it would just all disappear. You wouldn't have any of that data anymore. You would be starting kind of from scratch again. And so at that point, you got to think about a way of storing it. And so, one of the methods is using something like pickle, where you can pickle the data and then be able to store it as an object. The pickle is kind of a serialization protocol for doing that. I think we've mentioned before some of the security issues with unpickling things that you aren't sure what the contents are and so forth. And there's definitely disadvantages to it. Really, only one person can be working on this thing at a time and so forth. So it's pretty quick that you're moving into, well, I need some kind of other data structure. And it might be good if the data is independent from my application. And that's when you get into relational database systems, which is really what are super strong at that. And again, we focused on that a few weeks ago, and the idea of, creating tables. And one of the simplest ones is something like SQLite, where you can create a table using the SQL language. And one of the things I thought that was kind of cool that the author focuses on a little bit is talking about the differences between, like, SQL is a declarative language where what it's doing is you're describing through your code the desired end state, the way this thing should be, like what should be returned out of this whole thing. And I don't know, I guess I don't have a CS background, so I didn't really ever think of the difference between, declarative versus imperative. And,
right.
Python's much more imperative, and you're using this program and relying on different statements throughout the program to sort of move it toward this desired state, versus like just literally declaring what it should be, which is a different approach. And it's very interesting. So the problem is, when you're kind of thinking about these two realms, is yes, you could use actual SQL statements and create the tables and talk to the database and store things and remove it, but it requires a lot of code, a lot of planning, and a lot of stuff that kind of is, well, again, you're learning a new language, which a lot of people would rather maybe just focus on learning Python. And so that's where a tool called an object relational mapper, an ORM, kind of comes in. It sits between the SQL database and the object-oriented program in that language world, and it creates this abstraction, and it translates Python to SQL, and really the reverse too, so that you're really speaking in objects that are Python objects at that point. And it's really well written. It's short, which I liked about it. I think it kind of gets to the point very quickly. I think if this would have been included when I was just playing in Django for the first time, I think it would have helped me, because I definitely went to the Django website. I'm like, all right, everybody says you should go and do that tutorial. And man, this would have helped me kind of wrap my head, if you will, around this idea of creating these relationships between what is going to get stored to the database and then how it's kind of pulling and posting and so forth. Advantages, again, to databases are, the fact that it's shared, so multiple people can be looking at the data and it's stored independently. And there's all kinds of different types of databases out there that are popular. But anyway, so the ORM is really helping kind of create that link between the two. And then the other big advantage they have, and I think I mentioned this before another episode we were talking about migration, is an ORM, once it looks at your models that you've created for the database, it can go ahead and create, when Django, you use a command of make migrations. Mm-hmm. And that's basically creating a set of code that is, kind of creating the SQL commands that then get sent over to the database. And then there's a second command, which you've made those migrations to actually migrate it. Well, all those migrations are Python code that you can actually go and look at and kind of see what it's doing and how it's talking and kind of generating this code for you. But even more advantageous, we were talking about, the ability of source control and the idea of having versions and so forth. Well, the migration system can help with that too, in the sense that, very often you want to move your code around, and the idea of having your migrations with you is if you have a new database, you're not sitting there in a terminal and typing, create table, create these columns, create these pieces of data and so forth. In this case, with migration, you can actually have it, just stand up a new database and make all those changes for you, and it remembers all of those steps for you, which is really powerful and gets you up and running very quickly. So anyway, so ORMs are really powerful. SQL Alchemy is a very popular one. Things like Django have like their own built-in one, but it's something that I think can help you kind of wrap your head around that idea of like working with data a little bit. Again, keep you out of the SQL world and focusing in the Python world, hopefully.
Yeah, ORMs are a really, really nice tool. And, if I have to do anything that involves more than just a few lines of SQL, then I typically start reaching for the ORM, just because it really does make life. I'd rather work with Python objects, it's a little bit easier and more intuitive.
Yeah, totally.
Really like it. And I agree. It was a really, really well-written article, very clear. And I think if you're new to all this, even if you're not, it's worth a read. Just, it clarifies a lot of things and just a really good resource.
I want to shine a spotlight on another Real Python video course. It covers one of the main topics we discussed this week. It's titled How Python Manages Memory. The course is based on a Real Python article by Alexander Van Tol, and in the course, instructor Austin Sapalia takes you through low-level computing, specifically as it relates to memory, how Python abstracts lower-level operations, the Python GIL, the global interpreter lock, and CPython's memory architecture. I think it's a worthy investment of your time to learn how Python handles your data behind the scenes, how your variables are stored in memory, and when they're removed through garbage collection. And like most of the video courses on Real Python, the course is broken into easily consumable sections with a transcript and closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. So what do you got next?
The next one that I've got is another kind of heady, I'm going to call it heady, article from Brett Cannon, who is I just love the fact that Brett is so active in writing on his blog and putting all this stuff out there. Brett is on the steering council for the Python language. He works at Microsoft and is one of the big, which I guess now with Guido, because Guido now works at Microsoft. But it's he's just, he's like one of the, he's one of the head guys in the Python world. He's in charge of making a lot of important decisions and everything. And I love that, he writes this blog, and it's very clear that he's definitely very knowledgeable about Python, but there's also a lot of things that he doesn't know yet. And so it's just fun seeing someone at that level kind of being open and honest about that stuff. And he's got this series that he's been working on. I guess he's calling it the Syntactic Sugar series, but he's each article is like unraveling X in Python, and he might look at, like if statements or unraveling, I don't know, some other like the int data type or the tuple or whatever. And he digs into the bytecode, he digs into the C implementation, and he just talks about like, how does this thing actually work in Python? Like, what is really going on here through all the different layers? This week, or maybe it's a little bit older, it's from November 26th that he published this. It's called Unravelling Not in Python. And this one was really fun to read because you think of not, so the not operator works with Booleans, sort of, to basically reverse whatever the value is. So if you say like not, so if you have some variable called, I don't know, let's say happy, right? Happy equals true. Well, then not happy will be false. And so not, reverses that. But like, how does it do that, right? So like you can use not with anything. It doesn't have to be an actual Boolean type. You see things like if like you have a list that you're building up or a list that you're reading from somewhere, a list of things. And if the list is empty, you want to maybe do something. And you'll see people write like if not, and then the name of the list. And so how does that work? That's like this whole idea of truthiness and falsiness. And it is a fascinating dive, and it gets way more twisty and windy than you ever expect as to like how this actually works. And I'm not going to go through all of it because there's a lot going on there, and it's totally worth a read if you want to. But there's a list of what happens here that is, I think every Python programmer needs to know this list. But when I saw it, I was like, man, this is really good. Like I need to like write this down and just like kind of study this or like have it up on my wall for a little while. Basically, when you use not, then in the C implementation, it calls a function called PyObject_is_true. And this function returns the value true if its parameter is false, and it returns false if the parameter is true. And it sounds simple enough, but how does it determine that? And when you go through the code, the C code for this function, there's basically 6 steps here that it goes. If the value is true, like the literal bool true with a capital T, then it returns true. So because we're talking about this PyObject is true, so not returns the opposite of this, but this is true function. So if it's true, then the object returns true. If it's false, the literal bool value false with a capital F, then it returns false. So it just returns those, whatever goes in comes back out there. If you pass to it, those are the first 2 steps. The third case, these are what, like it goes through these cases in order. The third case is if the argument that I get is none, then I'm going to return false. Okay, easy enough. 4th step, if I've made it this far, I look to see what the object's _bool method returns. And as long as that return value is a subclass of the bool type, I'll return whatever that is.
Whatever it's going to represent. Okay.
So now this is getting a little bit more complicated, right? It's using like sort of this magic method bool. Has that been defined? If it has, does it return something? If it does, is it a subclass of bool? If it is, return that. Okay, well, there's some ifs there, and like, what if those ifs are like don't exist? And there's another sort of the last step. Well, sorry, second to last step. If the double underscore bool thing doesn't work, then it calls the len function on the object, len, and the len is. I'm not sure if the logic I haven't worked through at this point, you can like guarantee that this is not going to return or not raise some sort of exception or anything. But calling len on the object is kind of a complicated thing. And it gets into like, well, how does this actually work? But basically, if the length is greater than 0, then it returns true. Otherwise, it returns false.
Right.
But how do you calculate lengths on objects? Like, what does that actually mean? Well, he goes through all that. And that's where it all just gets really interesting because you see all these like caveats and like twists and turns. And it's just like, man, this is like a way more complicated problem than you really thought it was. And then the last step is if none of the above applies. So if you go through steps 1 through 5 and none of that had worked, well, then just return true. Just assume that it's true. Nothing else worked. So that's how you determine if something is true or false, and then not will return the opposite of this. But this list, this is what defines truthiness and falsiness. in Python.
Yeah.
And it was like, okay, I need to copy and paste, put this on a piece of paper, print it out, and put it up on my wall. And I was just like, man, this is like golden nugget right here of information to understand how that actually works, like what the interpreter is actually doing there to determine that. So I thought that was really, really cool.
Yeah, no, I like that as a resource.
Yeah.
Yeah. And then I need to have the obligatory Wayne's World reference at this point. So sorry. All right. So my next one is talking about memory, which is kind of interesting. We kind of touched on this in passing, but a recent video course came out that's based on a real Python article. The article was by Alexander Van Tol, and then the video course was created by Austin Sapalia. And it's generally just how Python manages memory. And so, again, it's kind of interesting because Python is an interpreted language in some ways, like it gets compiled. There are different implementations of Python. This article focuses on CPython, which is written in C. And Python code is converted to instructions. In fact, something that's kind of a thing that I thought was kind of cool about the article you're just mentioning is he uses the dis command to disassemble.
Yes.
And I mentioned that with Reuven last week. And I think that's, now that I know it, I'm like, oh, this is really kind of a neat way to kind of see some of that stuff. Not that you really want to constantly, see disassembled C code, but it could be useful for troubleshooting things and actually for learning a lot of things. It's very kind of cool.
Yes.
So in that process of this creation of CPython and everything inside Python is an object, and I'm guessing we might have said that already, but every single thing that you create inside of Python, a string, an integer, a list, what have you, they're all objects.
A function.
Yeah, a function. That's an object too. We talked about decorators in our very first episode, and how that, a function could be passed into a function as an argument, which is kind of weird and wild and very cool. And so inside of that, there's this structure inside of CPython that is called a PyObject. So that's creating these Python objects. And there's two things that you need to know about them in order to sort of understand what's happening with how Python's managing its memory. There's a object reference count, OB_REF count, CENT.
Yeah.
And then if you're not familiar with the idea of reference counting, when you assign, a variable name like, X equals this particular list of items or whatever, if you have that statement in your code and it gets assigned there, that's a reference count. So X is now referenced to memory, that object's been created and so forth. But if you were to say Y equals X, so now if you've messed around with lists before, you might have come across a thing where you end up kind of editing the same object and you're kind of like, what the heck's going on? I thought I was creating this separate thing, but it's actually referencing it again and kind of dives into some of that stuff. And so then the reference count would go up again. And the need for this is if eventually that object is no longer used or is somehow deleted or what have you, the reference count will drop off, and then the virtual machine that's running this code inside your computer, it knows then, okay, I can collect that memory and I can kind of free it up through this technique called garbage collection. So this article goes into all that kind of deep detail sort of stuff, very CS kind of level, but explaining it in a really nice way. The course is done really well with some nice graphical representations of all that sort of stuff. It goes into the GIL, the Global Interpreter Lock, which is one of those things that people talk a lot about when they talk about Python. And the idea there is really about memory, that if something's in memory and you have two different threads that want to modify that exact same thing in memory, that same resource at the same moment in time, that can cause really bad things to happen. And so the GIL prevents that from happening so that literally only one thing can access that piece of memory at a time. And there's lots of things going on with sub-interpreters and other ideas that are out there that we've talked about. But in general, that's what's happening now. And so, one thread should be interacting with a shared resource. The example they use a lot throughout the article and in the course, they're talking about memory being like pages in a book. And you don't want two authors writing to the same page at exactly the same time and how that could become a mess. It dives much deeper into the actual layout of the memory management. And I won't spoil the whole thing for you, but it talks about that you have blocks of memory. The blocks of memory are stored inside of pools of memory. And then inside of that, there's these arenas of memory. And so they're kind of like getting larger as we go. And there's different things that are going on inside there to basically manage, okay, when do I free up blocks? How many different blocks are inside of a pool? And it depends on, again, object sizes and things like that. And it's really interesting just to kind of get an overview of what's sort of happening and kind of get an idea of some of the links that had to go to manage memory inside of Python, and ties into a lot of the other things where we've talked about, references and these kind of other ideas inside. Okay, well, does Python use pointers? And it kind of talks a little bit about that too. So I think it's a good way to kind of get you going. And I'll link to the course. So good job, Austin and Alexander.
Yeah.
I guess that moves us into projects. I want to start real quick. I was really surprised. I got a email from Near, who's the person who's working on Jupylet.
Oh, yeah.
And so I had mentioned that I was having problems, and I was, complaining in my own way of saying, oh, I got a complex MIDI setup and blah, 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 and so forth. And so he actually released an update to the project and sent me an email directly, and it was really cool. And so I updated to it, and then he showed me a couple additional methods that have been added that actually allow you to list what the ports are. And oh my gosh, it works great.
Oh, cool.
And so, I was able to set it up, plug my MIDI device in. I was able to see, okay, that's the port that's coming off of my audio interface. And then,
oh, awesome.
Yeah, I was playing the different sounds inside Jupylet. So very excited to go a little further on with it. And might try to see if I can get him to come on the show to talk a little bit more about the project and kind of what plans he has. And again, anything about...
That'd be really cool.
Yeah, anything with gaming and audio and all that stuff, it's definitely something I'm interested in. Haven't done much of that lately on the show. So
yeah, it's definitely a cool project.
Yeah, I'm impressed with it. I'd like to see where they're going with it, and
yeah, for sure,
how other people might want to get involved with it. So what do you got for us as far as a project?
Project I got this week is a fuzzy project.
Fuzzy.
It's fuzzy, yeah. It's a Python fuzzing engine. Like, what the heck does that do, right? So this is a really interesting tool that you can use to test your projects to see how well they can handle just like random input.
Okay.
A testing technique that, can really help uncover like some crazy like edge cases, right? That like no one ever would have thought about because you would never have typed that in to your program. But the fuzzer will do it for you and mimic that one user that, who's going to be like, well, I tried to do this. And you're like, well, why did you try to do that?
Thank you.
But yeah, right. I mean, we'll fix it, but like, you're probably the only one that's going to find it now. No, it's a really cool project. And this is like, if you're working on a project that is going to be run by lots of people, it is not a bad idea to use these kinds of techniques to uncover weird little edge cases that, and that you didn't think about, because you're not going to think about all sorts of this kind of stuff. But basically what it does is you tell it like you give it like an entry point to your application somewhere. It's like, okay, here's where you're going to start running it. And then it goes, all right, well, I'm just going to throw it a whole bunch of different kinds of data, a whole bunch of stuff, and just see if I can get this thing to break. When it breaks, you'll get a report of like what broke and why it broke and everything. It's interesting. It works with it can actually tell you the coverage that you got out of it, so it can keep track of like what lines of code were run before it crashed or it made it through, so you can see like where all it's reaching throughout your program. And they recommend that you use Python 3.8 or better, because in Python 3.8, they added a new feature to the language for opcode tracing, which means that Atheris can monitor not only every line that was visited and every function that was called in your program, but it can actually monitor every operation that Python performs and what argument was used on that. So like kind of going back to like this disassemble thing, like it can look at all the individual operations, because one line of code might actually represent many different opcodes that get generated there. But anyways, yeah, just a really cool tool. Combining something like this with, say, something like the hypothesis framework, if you're familiar with that, can be really powerful tools to just find some really crazy edge cases that you never would have come up with otherwise, and really, I guess, produce a lot of confidence in, how rugged, is that a good word for it? How rugged your application is? Yeah.
Battle test it.
So, yeah, exactly.
Yeah. That's something that we had to do occasionally with creating not only data, but just to sort of test for weird sort of circumstances of, data coming in. It's kind of like another way. We were talking about that way to build your own data sets last time. Mm-hmm. And so I think that any of these kinds of tools that can help you kind of think outside the box, I mean, that's really awesome to plan what might be coming in.
Yeah. And I'm not sure, I'm curious, I'd never heard of Atheris. What is Atheris? Is that like a Greek god or something? Or I've never, and I haven't seen anything on why they called it that. If you Google Atheris, then the Wikipedia, there's only one Wikipedia page that matches this. It's a genus of venomous vipers.
Oh.
So I don't know if that's the inspiration for this name. That it's
it's trying the snake route. Yeah.
Yeah. Attacking your Python code. Yeah. But anyways, there you go.
My project is actually from a couple of weeks back on PyCoders, but I'm intrigued by it. And now that I've researched the project a little bit further, it's actually a pretty old project. It's over 6 years old. And it's a static website and blog generator. It's called Nikola, like Nikola Tesla. I don't know if this happened to you, other developers out there, where somebody has tried to convince you to help them make a website, and and maybe you've used a tool like WordPress or some other kinds of things like that. And my problem with WordPress is I feel like there's a racket that is involved with WordPress, which is basically having to pay people to protect your website. This whole idea of it feels like a mafia scheme sometimes of be a real shame if something bad happened to your website, wouldn't it? And I just feel like it's just, I don't know. Anyway, so the idea of a static site, in my opinion, is great. The idea that it's just HTML and CSS, and they're just files that are on a site. You don't need as much of as far as a web host. You have much more simple web host. Kind of like going back in time somewhat.
Yeah.
So this thing can take a blog, and it uses restructured text, the RST file format, which there's lots of tools to kind of convert stuff back and forth, but that's what it kind of uses as its source to get going. And I think the thing that I was most impressed with, I didn't spend a ton of time with it, but that's what impressed me, is I didn't spend a ton of time with it, and I was able to set it up.
Yeah.
I was able to run the demonstration. I was able to get an actual demo site up and running in less than 10 minutes. And I was like, okay, this is great. And so to me, that means that now I can kind of go back and spend more time with it, now that I can kind of see what it's going to build and what it's going to create here. And I definitely am a fan of static sites, especially if I'm going to build something for a friend or a family member or something like that, where I've been given those responsibilities. I dabble in design, but it's definitely not a forte I have. And so the idea of building something and that it can kind of just sit on the web, and I don't really have to worry about all these weird dependencies that could get attacked or whatever. It has to be running on an actual Linux machine up in the cloud or a Docker container or something like that. It's nope, they can just be files hosted somewhere.
Right. Yeah, exactly.
Which is very cool. So anyway, I think it's a cool project, and there's 190 contributors. It's a decent sized project. So I think it'll, be around for a while. If you're looking for a Python static site, website generator or blog generator.
Yeah, I'm a huge fan of static sites myself, and I feel like there's a tendency, I've never been really a web developer.
Yeah,
I've had to make a few websites. I've made a portfolio website for myself. I've helped on things, but I'm not by any stretch of the imagination a web developer. And kind of what I've seen of friends that have really kind of gotten into that, there's this shiny new object syndrome, which granted, that's not just
that's
web
development.
I feel all developers fall prey to this, right?
Right.
But there is a lot where it's I'm going to set up my, it's going to run on Node.js, and it's going to, have all this stuff. I'm going to use, the React front end framework and Tailwind CSS and all this stuff. And it's what are you making? It's just a single page, like little things. It's like, man, like, why not just make an HTML file and put it up somewhere? Why go through all that trouble? I feel like for like small sites where you just want a little bit of information, or it's like something like a blog is also another like very perfect use case for these kinds of things.
Yeah.
The static site generators, what I like though is they help make the management of that easier, right? Like you can kind of like bootstrap the creation of everything, and it makes it easy to where like you literally just have to like go in and maybe type some like markdown to create a new blog post or restructured text or whatever it ends up being. So yeah, I'm a really huge fan. Even then though, I feel like there's a lot of static site generators that get overcomplicated. And it starts to kind of feel like there's like kind of this bloat going on. And it's like, I don't need all this. Like, I really just want like something super simple.
That's what I meant. Like I was able to run the demo and get it set up in 10 minutes and it actually finished. And I was like, okay, great. Because I've done that. I've spent a couple hours like trying to figure out what this thing's trying to do and just failing throughout the demo steps to get something set up. And I'm like, okay, this is not a good harbinger of the future for me with this project.
Yeah. But yeah, when I was looking through like Python static site generators for my own website, I have that is just sort of my portfolio website. I looked at Lector, and I looked at, I can't remember the name of, there's another one that had like a CMS built into it. I can't remember now. And then I looked at Pelican and I looked at Nikola. And Pelican and Nikola were like the only two that I was like, okay, these I can see myself actually using. And I ended up going with Pelican instead of Nikola. But it was mainly just because at the time I felt like maybe there was like more of a community around it. It's like a lot of people are using Pelican. But yeah, Nikola is also a really great option. I just love the simplicity of it. So yeah, definitely a super cool project. For sure.
Yeah, cool.
I also really like, we should just mention briefly, one of the cool features that Nikola has is these importers that you can use to import. Like if you already have a WordPress blog, there's like a Nikola import WordPress command, and you can like convert your whole WordPress blog into a Nikola project. And they've got one for Blogger, for Goodreads, for G+, for Jekyll, Tumblr, and then arbitrary web pages as well. So anyways, good stuff.
All right. Well, thanks for bringing in all the articles and projects again this week.
For sure. Yeah. Thanks for having me on.
All right. We'll talk to you soon.
Yep. See you later.
I want to thank David Amos for coming on the show again. And I want to thank you for listening to the Real Python Podcast. Make sure you subscribe to the podcast in your favorite player. And if you like the show, leave us a 5-star rating and a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.